Welcome everyone to the October edition of the WARACI Chemaraderies event. My name is Terry Humphreys. I'm from Curtin University. I always forget to introduce myself, so I actually remembered for the first time this year, just in time for the second to last one. So I'd like to start off by acknowledgement of country. I wish to acknowledge the traditional custodians of the land we're meeting on, the Whadjuk Noongar people. I wish to acknowledge and respect the continuing culture and the contribution they make to the life of the city and this region. So before we start, I'll make a quick introduction. So today's talk is by Matthew Deaves on what makes chemists the best occupational hygienists. So I think that's quite well fitting with this is WorkSafe month that I got an email about 3 times from by Curtin today. Matt Deaves received his MChem from the University of York in 2002, not 2022, beg my pardon. That's it. It's kind of, been doing all this before he even gets his degree. He's been a chartered chemist since 2008. He has a diverse set of academic and experimental skills to add value to industry segments including petrochemical, fast-moving consumer goods, and more lately occupational and environmental sciences. So Matt boasts working on high-density rocket fuel, airborne contaminants in childcare, asbestos in beer, and men's hair removal. So he's also passionate about sharing love of science through effective science communication. So please welcome our speaker.
For a second.
Yeah.
Thanks very much. Maybe I can clip this onto my shirt, maybe. Likewise, start by, can everybody hear me okay? I mean, it's a small room, right? Likewise, also like to extend my regards to the Whadjuk people of the Noongar Nation, their lands and waters, their elders emerging, past, present, and all due respects are paid. I asked Terry to leave this up on the board for a moment, not just because of the 2022 mistake, which is kind of amusing, but just to mention that hopefully I'm going to get to talk about most of this, maybe not all of it, and some of it we can talk about afterwards. But particularly we'll touch on hopefully some chemistry. I'm looking around the room and I'm feeling a little bit nervous because it is a few years since I was a dedicated to my research kind of chemist. But we'll have a little bit of a nerd off at some point, I'm sure. It is true to say that at one point I did consider myself a rocket scientist, and we'll go into that and hopefully get a laugh out of it a little bit. I'll take questions throughout. I don't mind taking questions throughout, or you can save them all up until the end. I'm going to switch over. Do I just plug it in and press the laptop button? That's all right. I better. Let me just put my password in first. Oh no, it's done. Face recognises me, which is a little bit creepy. All right, I think I set this up correctly before. I was saying to a couple of people before that this is the first time that I've done this presentation. Normally what I do is kind of just hash the fun and interesting parts of other presentations together. So I've got some notes. If I'm going a little bit off topic or astray, just hold in there, hang in with me. It is a little bit of a new one, and you will see throughout the presentation that I do send myself up a little bit, so hopefully you're laughing with me, at least at some points. I'm going to take you on a little bit of a journey, starting roughly 1996, the age of wonder. We were, Wonder Wall at least. It's a good pom joke, right? Oasis and things. probably and I put 1996 in the middle because obviously it genuinely was the year, but also it covered up the fact that every single person in that photograph was smoking a cigarette and hiding it from the person taking the photograph, myself included, which is a guilty sin. We might get onto that in one of the bits that I talk about with inhalation toxicology and those kinds of things that I went on to look into. But yes, that was what we affectionately called our boy band. It's not entirely fair because Alice, sitting at the end, was in our boy band, but she didn't mind. My parents had imagined that I would go to this quite nice school that I went to, that I would do well in my A-levels, I'd go on and study medicine. That was their aspiration for me. It got to filling in my UCAS application. I'm a POM, by the way, just in case anyone hadn't realised. Filling in my UCAS applications, and I kind of looked at the medicine degree and went, 5 to 6 years at university, that seems like a bloody long time. So in the end, I went for 7 years, and probably didn't quite get the impact on what my parents were expecting from me. Just a quick show of hands. Is there anyone in here with 0 degrees, with no degrees at all? So I just don't want to lose anyone. Is there anyone here with more than 2 degrees? Okay, you might not enjoy all of this, but I'll try and keep you in the room. At the very least, there's pizza at the end. You're probably going to find me a little bit odd because I am. Occupational hygiene. It's weird that I'm in this room actually because the Australian Institute of Occupational Hygiene does their sundowners here, their Chemaraderies equivalent, sponsored by the Chem Centre, and we come into this room. It feels very familiar. I don't normally stand this side because, we'll get into that when we talk about how bad a hygienist I am. But honestly, it's quite a pleasure to be standing up here in front of you. I'm going to tell you a little bit more about my journey and some of those rocket fuel type fun and interesting stories. I will talk a little bit about what a hygienist is and how chemists are making a difference. They genuinely are making a difference, and it's an area where we'll continue to see that difference. Very quickly, my employers, because they're essentially funding me to be here. 21,000 people in 450 offices is probably the tagline that I want to mention there. Complex world, clear solutions, leading with science. These are the taglines. It's why I joined the company, because I actually want to be a scientist, and everybody in Tetra Tech, from the technicians that work in my team all the way through to the CEO, they're all scientists and engineers. So it's a really great company to work for as far as consulting companies go. A lot of offices, which is really great, and a decent presence in the Southeast Asia Pacific region. Papua New Guinea is not in that picture. My team specifically has 4 people who can legitimately call themselves occupational hygienists. Whether they do or not, it's up to them, but they can. And we have 6, those 4 plus some extras who are licensed asbestos assessors, which is becoming more and more of a thing, and is a very big and important part of our business already. Tetra Tech in Australia and New Zealand is split up into 4 divisions. You may recognise some of those logos, you may not. But I'm in the Tetra Tech coffee part of the business. We are franchised under the Tetra Tech mothership, and that's where the pointer would have come in handy. And that's where the occupational hygiene and hazmat side of things come in. So back to that picture. Study so you don't have to do the dishes, and then of course that's what you spend a lot of your time doing when you're in certainly in your postgrad. I think we had the undergraduate teaching lab staff do a lot to carry you through, but when you get into postgrad, you soon realise that there's nobody holding your hand for you and nobody wiping your nose. You kind of got to get on and do it. two of my arch nemesis. This chap over here with the wonderful curly moustache is the best photo I could find of him, actually, and I don't think he's changed one iota in the other photos that I found. This is a chap called Professor Klaus Müller-Detlef. Yeah, and he was as hardcore as he sounds. Not that he was into that kind of music, but he was a ball breaker of a professor, famed for weighing assignments. Yeah, so we thought work harder, not smarter. No, we thought work smarter, not harder. Go for the thicker paper, go for the, spreading things out to fill more pages. No, he had that measure as well. So he started to normalize by thickness as well. So he'd weigh them and he'd measure them, and he weighed and measured us all. Don't you worry. The other nemesis, Physical Chemistry by Atkins, that's actually the edition that I have. It's not a picture of mine. I have that edition rather than any of the new ones, which I can only hope are a little easier to read. This one did have a free CD-ROM, which I don't think I ever saw, but it probably got used as a coaster or a frisbee or something in undergraduate days. The irony of it is, Klaus Müller-Detlef was and is a specialist in mass spectrometry. And he pioneered some techniques that I ended up having to use, particularly at my time in BP, which I'll talk about shortly. And physical chemistry was absolutely key and core.
I just thought it was interesting. This was in England.
Mm-hmm.
Yeah. So I had an earlier edition of the very same textbook when I was at uni, many years before, here in Australia.
Yeah, it's still scary to this day, I think.
It was a good textbook.
It is a good textbook. We're going a little off topic, and I know I'll do this multiple times today. One of the great things about this book, and one of the things that I found it in the end to be a really great resource for, is actually you can go to the bit that has the bit of information that you need. And you kind of don't have to remember the whole thing verbatim. And I think it was that I had to get over was the idea that you had to know and understand books, or you had to read the entire paper. I mean, do read the entire paper, but you don't necessarily have to dwell on every single part of the entire text.
Australia, it's upside down.
It's the other way, is it? Yeah. The CD-ROM goes in backwards.
The only physical chemistry book that ever got published. Worldwide.
I think it is. Did anybody else use anything other than Atkins? I don't know. That sounds. So I've fast forwarded a little bit, and maybe in future iterations of this presentation I'll throw in a little bit more about the undergraduate years. But I wanted to get out of those as quickly as I possibly could, because I didn't find it a lot of fun. I found it quite difficult, actually. I was fighting against the system, trying to live my boy band days. But I managed to find myself in a green chemistry and clean chemical technology research group after I graduated, and I was working on some really fun and interesting chemistry that I thought was actually going to change the world. That I actually thought I was going to do things through chemistry that were going to change the world. How misguided I probably was at the time. But one of the things that I've found really interesting about working in research was that you could challenge the status quo on things, and I ended up getting into towards the end of my postgrad, getting into a bit of a bun fight with some very knowledgeable people, probably in a quite arrogant way, believe it or not. About whether or not the chemistry that I was doing demonstrated proof of the Ene reaction. I don't know if anyone knows what the Ene reaction is, but it's essentially, I'm trying to, in the research that I was doing, I was trying to stuff two long chain, they were tall oil fatty acids actually, trying to stuff them together. But I could get the reaction to happen whether or not I had any dienes present. So if I had only oleic acid, I could still do the chemistry. So long as I had my catalysts in place, I could still get these two tall oil fatty acids to dimerize. So I was dimerizing them. Basically what we demonstrated through a little bit of Raman and quite a lot of magic angle spinning solid state NMR, which is a very cool technique that was kind of emerging, it wasn't brand new, but it was kind of emerging at the time. We were able to demonstrate that we were structurally changing the surface of our catalyst, and the careful observers amongst you will say, well, then it's not a catalyst, because essentially we were destroying it, but the reaction wouldn't proceed without it. So I'm going to claim catalysis, heterogeneous catalysis, whether the purists like it and want to throw things at me or not. But we were therefore, in a roundabout sort of way, demonstrating that actually the surface was providing the enol part of the keto-enol tautomerism that's required in order to get this ene reaction, or to demonstrate that this ene reaction was proceeding. And I'm starting to feel faint, in case anyone's wondering, with all this chemistry talk. That was a really great project. Gave me access to lots and lots of different tools. I worked in in a number of different research departments. And on the back of that, I applied for my fellowship with the Royal Society of Chemistry. And they said, absolutely wonderful, this is going to be such a great thing for you. It's going through the motions, we'll let you know. So that was 2005, 2006, when they said, we'll let you know. I'm still waiting. So a case of nearly. So I realised that I had to go out into the big wide world and do an actual job. I started out at BP working on just that molecule down there. It's called tryptane. Keep your eyes open from this point onwards. I've started to throw in a few chemical formulae. If I get any of them wrong, shout at me, but you'll soon see a thread. I noticed a thread while I was eating my lunch today, and it goes all the way through, so I'm going to play on it a little bit. But tryptane, also known as wonder fuel, it's used as an octane enhancer for the aviation industry. The molecule that's above is tryptane bolted onto hexamethylbenzene, and the really interesting part, and the Klaus Müller-Detlef part of the story, is that I was able to demonstrate by using carbon-13 methanol that the carbon, the methyl groups, were racemizing with the hexamethylbenzene, and using a pretty cool mass spec technique, which I'm really not going to go into unless you're desperate for it. Using a really cool mass spec technique, we could show and we could demonstrate that that hexamethylbenzene, carbon-12 hexamethylbenzene, normal, with heavy methanol, was racemizing, and it was a massively unexpected result, and I can see all of you very perplexed about that. But it challenged the understanding of how structurally strong a benzene ring really is. It wasn't at all the point of why I was there, but it was the avenue that I went off down, and so BP said, that's not what we want you to do. We want you to make more of that stuff, not do cool and fun, interesting research. So goodbye. So they punted me out into a company that they gave me a couple of projects. The first one in the middle, I made sure the picture of it was nice and big. That's not the product they asked me to work on. Those are the swines that beat me to the market with a hair removal cream that says gentle on the intimate areas. In fact, all they did was they took the potassium thioglycolate out of the product by about 90%, whereas I kept mine in at full strength, full burning strength. This, Keely, I'm not going to go down there, so to speak, but I kept mine at full burning strength, so it actually did the job that it was supposed to. You get what it's supposed to do, right? And they got all the market share, and the Veet version for that, the Veet for Men, which is the product I was working on, did not. So that company said, look, we're not going to get rid of you, but we probably need you to work on something else. There might be some POMs in the room. Again, a really awful grainy picture, but does anyone know what that lady's all about? The shaken back lady, yeah? So she would, in the advert, she danced around her, I'm not going to do it, she danced around her house shaking this product around. That's not the product I worked on, right? That was the market leader at the time. Again, sorry, that was the market leader at the time. But all it did was, it just sat on the surface and then you vacuumed it off, so you were vacuuming. That's what got your carpet clean, but it would leave some fragrance behind. So I wanted to design something that would actually penetrate into the pile. And I did so, and then I ran up against a bit of a problem that caused the end of that next job, which was this white powder down here. I've labelled it. It was silica, but the silica that I tried out, and I had it in this formulation, you could spray it onto and it would dive deep into. But there was two problems with it. To get it effective, it had to be so fine that it was an inhalation risk. And that kind of piqued my interest in the inhalation toxicology. But it would also, with water of hydration, it would heat up quickly. And it started burning carpets. Like, it would actually have enough heat in it to start to smoulder carpets. So I said, well, we could use it in other ways. And they said, you could. Bye. So it was at that point I escaped the country, and there's a little bit in between, but I made it over to Australia, and some people wanted me to do some work on, those types of compounds that I'd been looking into for that company. I should say that for that company that I was working on those two fast-moving consumer good products, they did have me working on some really interesting projects. I was mentioning to somebody earlier, that was to do with legacy, and as in the legacy of how much are our shareholders going to be up for because of all of our legacy of nasty wastes and those sorts of things. So that kind of led me into a consulting space without actually having to do the hard yards. Another formula you'll see, there's silica in chrysotile as well. So chrysotile, asbestos, and all of the other asbestiform minerals have been a big feature of my time in Australia since arriving in Australia. But with the companies that I worked for over here on the lab side, but also on the consulting side, things like, anyone know what that is up at the top right? There's a bit of a blob. It's a caterpillar. It's got a nose as well, if you look. But anyway, that's PFOS. So the whole AFFFs, PFOS, PFOA, the firefighting foams, and the problem with Teflon and all those sorts of things. Been working quite a lot on that, particularly around the measurement of it, and particularly around the ability to measure it using isotope dilution down at parts per trillion and parts per quadrillion levels, which that's cool science. We can talk about that later. Anyone know what this one is?
PAH.
It is a PAH. Which one specifically? I took the easiest one. I mean, it's benzoate, so it's the worst one. And that was a study that I did at a childcare centre in South Australia, which was reporting levels of benzoate at concentrations which would really boggle the mind. But the fact that it was at a childcare centre, that led me into doing health and environmental risk assessment in a more quantitative way than I had ever done before, where it's not enough to do finger in the wind, because it really mattered. And I think that's pretty much the journey to here. Now, neither of those people are me, so I've done it again. So what do we do? I mean, this lady on the right-hand side is in my team. This gentleman on the left is something else entirely. I've put a little chemical formula. Does anyone know what that chemical formula down there is for? It's spodumene. But again, silica, as is becoming, hopefully you're seeing the theme that's coming through there. So, I mean, other than the fact that he's probably as chill as you could ever imagine with that amount of lithium all over him, and probably healthily ingested, because if you look closely, he's wearing his snood under his mask, so his mask is completely redundant. So he'd be well and truly dosed up. But the worrying part of it is the silica. that's there, and it's been a persistent theme through my work over the last 5 or 6 years, and is a very big focus for my team. So what do? We generally speaking, most of our work, particularly in my team in Tetra Tech, is looking at airborne, inhalable, respirable contaminants that can hurt people in the workplace. And that's a good nutshell for an occupational hygienist. Whether that's dust, generic, not otherwise specified, whether it's asbestos, whether it's welding fumes, we do some gases and vapours as well. But an occupational hygienist is generally concerned with things that are going to affect a worker, not necessarily, we're going to come on to it in a second, not necessarily acutely. So somebody might get hurt from falling off a ladder. That's a health and safety generalist. That's not usually an occupational hygienist who's going to get involved with those acute harms. We're more inclined to be involved with the chronic, the things that are going to have a lasting effect on you or are going to hurt you in 20 or 30 years' time. So we will concern ourselves with acute hazards, and we'll address those, and I'll show you some of the methodologies that we use. But we're more interested. I mean, it's a relative scale, right? In those chronic occupational diseases, chemicals and other agents is how the occupational hygiene world describes what we're really interested in. I don't know what those other agents are if they're not chemicals. So it kind of grates on me a little bit, but forgive them that. I mean, it's a science born of some necessity, born out of necessity, with some really, really great and strong people, including one very notable West Australian gentleman called Barry Chesson, who is probably has been at some point in time an active member of RACI as well. Whether by education or necessity, we are getting, the occupational hygienists are getting involved in industrial processes and trying to improve them. We'll go through a bit of a hierarchy control, why they would do that. But I would say one of my most important roles, particularly when I'm working with complex situations, is providing a conduit, providing really good advice to senior decision makers, because without the ability to communicate those the issues and how to address them, how we put controls in place, and why they have to, what their legal duty is, but also what the legacy that they're going to be responsible for is, and most of the time that's a financial legacy. I mean, let's be crude about it. People don't really care about personal responsibility. It's what do the shareholders expect. Some of the new laws try to change that a little bit, but what we're not, though, and I'm sure as chemists we get this all the time when people say, "Oh, what do you do?" "Oh, I'm a chemist," and they're like, "Terry White or no, not that." "Oh, so you can cook meth?" I don't know, maybe just me that gets that, maybe that's where I live, but yeah, I'm sure we've all had it at some point. So we're not pharmacists. As chemists and as hygienists, we're not the health and safety rep, and we're not the do-gooder that's going around telling everybody what to do and how to sit. We do a lot of that, but or we can do a lot of that, but it's not necessarily the prime role. We're not cleaners, dentists, dental hygienists. We get confused with dental hygienists all the time. Definitely the cleaners thing, especially when you're up on a mine site. If you say you're an occupational hygienist, expect that as a response. Can you come and clean my dunny for me and that sort of thing. We're not specifically counsellors, but in the new legislation, and I welcome it very much, is psychosocial hazards, and the role of an occupational hygienist is evolving to accommodate those psychosocial hazards, and so we're all retooling a little bit to try and identify them. We'll come onto those sorts of things. So anticipation and identification. We're not necessarily the ones who solve that problem, though, so I want to make that clear. And we're not window crackers, so the old adage used to be dilution is the solution to pollution, or if it's a bit smoky, dusty, stinky in here. Let's just crack a window and that'll sort it all out. That's not going to be an occupational hygienist. We generally don't do ventilation, although again, COVID happened, and all of a sudden occupational hygienists are being asked about ventilation. As mechanical, as far as I'm concerned, there are some people, and generally what you're then trying to do is as chemists, as occupational hygienists, as you probably know, you end up working with everybody because you become that bit of a conduit. So why are hygienists important, but why are chemical trained hygienists important? Is because they have that ability to talk to an academic one day, a microbiologist. Is it just me, or does the Nobel Prize for Chemistry always seem to go to a biology field at the moment? Is that just a bit of a thing?
This year? Was it chemistry this year? It was very chemistry.
We'll maybe pick that up afterwards. That was an aside. But anyway, talking to the analytical chemists, I'm actually going to talk a little bit about it because it's probably where I still keep my toe in and my eye on the game is with that analytical side these days. Probably I've gone past the point where anyone will trust me with an instrument anymore, but I can certainly review it from a quality perspective and an academic perspective. The why goes back to that statement on the left. You're 15 times more likely to die from a work-related health condition than from any accident, whether that's at home, at work, or at all. And in Australia, 250 people will die from a preventable occupational injury, while 2,000 will die from a preventable occupational disease. So it's quite a lot more that are going to go on and develop a chronic condition than are going to be affected by something that happens, a mining accident or a truckie. So you've got to take that context. That's all workers, and I do include the transportation industry with that. I did put some just some ideas about the routes of entry, how people end up in Occ hygiene. It's probably not super interesting. It's more relevant to when I give this presentation in a couple of weeks to a bunch of students. But Occ hygienists are generally sourced from scientists, health professionals. There are postgraduate qualifications in it. There's not that much of an entry via undergraduate degrees. There are some undergraduate degrees around the world, so you can go straight to masters through an undergraduate degree. It doesn't seem to be a popular thing yet, but I think it's a growing and emerging. I think ECU and University of Wollongong are both trying to expand their masters courses to be undergraduate degrees as well. They may have done so already, so don't let the AOH know that I don't know that. So our specialist, our superpowers, according to me, that really do relate. This is the sort of crystallisation down into why chemists really do make the best occupational hygienists. The health without hysteria. Now, this is never, over the last 2 or 3 years, this has never been more relevant, and I've seen it. And this is where my burning passion for effective science communication comes from, because okay, I'm going to stop just 1 second. This graphic really grinds my gears, and if anyone gets the joke, then I'm really proud of you. But because it's a lock. Anyway, health without hysteria. Yeah, we do know what's in it. We do understand the difference between sodium, chlorine, and sodium chloride. The sodium and chlorine being pretty dangerous, and sodium chloride not so much. Or whether it's thimerosal or any of the other ingredients. They're trying to kill us. And I'm not going to go down the vax versus anti-vax perspective, but I would hazard a guess that most of you in this room would have a reasonably good idea of what's in the vaccine if you've had it. I would say that's a pretty safe bet. You'd know what most of the ingredients are. So I'm not going to go through them. The other superpower that I really, really believe in with chemists, and my wife thinks that I'm some kind of savant. I'm really not. But we are comfortable with numbers. Numbers in any aspect, and I think I think I'm speaking for all of us when I say that numbers, units, orders of magnitude, putting things in context, grouping numbers, scaling things very easily. I asked my wife if she knew what 14% of 50 was while I was putting this presentation together, and she just looked at me like I was some kind of jerk and I was trying to make her feel like an idiot. I'm like, but that kind of stuff we just know, like we just do, because it's presented to us from day one, year one undergraduate. Is you just get ready to be bombarded by numbers, by facts, by data, and have the ability to then to turn that into some sort of information. With my team, I talk about turning grapes into wine. I'm not turning water into wine. I'm not that good yet. But we talk about how do you take data. We generate such huge amounts of data. You've really got to focus in on turning that, bottling that down and turning it into something that you can drink. No. Something like that. And then the biggie that I'm going to talk about a little bit more now, recognise, evaluate, control. That's the Occupational Hygienist mantra. Recognise, evaluate, control. So we are looking for hazards, we're evaluating those hazards, and then we're going to try and control the risk of exposure to those hazards. So everyone would recognise the hierarchy of control. Most people will see it drawn as a pyramid, or an upside-down pyramid. I kind of like this representation of it because I have an understanding, and I've worked in industry, and I realise that for the most part, wherever you get up to in the hierarchy of control, you're probably giving some consideration to all of the stuff that comes beneath it. If you can't quite get to elimination, because you still need to do heterogeneous catalysis, you still need to turn methanol into tryptane, or methane into vinyl acetate monomer, which is where that tryptane story should have started. I'll talk about that another time maybe. You can't eliminate the need for those chemicals. You've got to turn things into other things. But what you can do is work your way through the hierarchy of control and have an appreciation that at no point in the hierarchy should you be getting rid of the need for the stuff underneath. It's a bit of a misnomer, I think. Is people talk about PPE being the least preferred. Absolutely, it is the least preferred measure of protection for a worker. But that doesn't mean you shouldn't have it there. That doesn't mean that we shouldn't be anticipating what could still go wrong. So if you've eliminated, there's a likelihood that you've gotten rid of all of those high risk factors. There's always going to be others. Yeah, so we as occupational hygienists still have to anticipate what those might be, and still have to work to the lowest. No, I don't mean that. The worst case scenario. I was going to say lowest common denominator, but it's the worst case scenario. We've still then got to take that every control measure through the process and go around and around and around in the cycle. So anticipating what might be coming up, recognizing the risk associated with that hazard, evaluating, putting in good control measures, like things that are sustainable, things that are actually going to work, and that's out of the hierarchy of control, so that that whole wedge is blown out. And then we've got to confirm. So this is about the ongoing monitoring. We've got to measure things, and then as we're measuring them, we're then able to anticipate what may be going wrong, what may be outside of our control boundaries. And as chemists particularly, we're able to see those control groupings. So whether in occupational hygiene, we might call them specific exposure groups, these SEGs that we talk about. chemists are really good at sort of lumping things together in scale or in orders of magnitude or in, commonality that perhaps a health and safety person may not see. What I typically see, particularly if I go to industry, chemical industry maybe, not so much, but mining, if you've got the health and safety guy or girl, there's going to be 1,000 sects. Like they're going to see everybody's job as completely unique, and everybody's task as way more hazardous than it usually is. Whereas I find people with a good scientific background, particularly chemists, they're able to kind of crystallise that and make a bit more sense. And then you can come up with pragmatic solutions, which I may go on to. The 5 biggest challenges. Yeah.
Sorry, Matt, would an important wedge be communication?
Yep.
Because you've got to tell the whole industrial workforce about what you're doing and what you're doing to get them on board, otherwise it doesn't work.
Yeah, I mean, it probably wraps around all of that. So part of the training for any occupational hygienist is that communicating with people at every single stage of that. I might have a slide that talks about that, in which case I'll move it for the next time. But yeah, absolutely. The communication is the absolute key. So whether I've been doing welding fume assessments on a pipe laying vessel off the Northwest Shelf and being mobbed by, union to the max type people just because I'm there doing some monitoring, I'm trying to establish whether or not there's a hazard and whether there's a risk of them being exposed to that hazard, and then what control measures we want to put in place. Bang, I'm on board, I'm being mobbed by the union people, and the captain of the ship is nowhere to be seen. You've got to have that communication skill, and you've got to be able to communicate with all those different levels. I'm sure I had a slide that talked about that. The biggest challenges, though, and we'll talk about how to solve them in the next slide, but robust sampling. So whether that's going out with a clipboard and taking a sample set, that's more sort of, what the geography majors did. We would go out and actually measure something. I'll go back to that picture that I showed earlier of the guy covered in spodumene and one of my staff, Con, doing the measurements on him. We're measuring him for respirable crystalline silica in that picture. We've got to be out there robustly sampling, and I'll talk about that in a bit more detail in a second. We've got to get used to doing quantitative assessments, no more of this finger in the wind stuff. The qualitative is a dying part of the craft for occupational hygienists. We've got to get into the space where we're accurately, scientifically measuring things, and that involves scientists at every step of the process. Again, we'll come on. The exposure groups we talked about earlier, setting them, understanding them, and being able to follow the entire process through, so you can see what exposures they and the interrelated components for those exposure groups, what their risk is. Excuse me. How am I doing for time? Did I start late? Standardisation, workplace exposure standards in particular, they're really important in the occupational hygiene world. There's not enough of them, and they're not based on good enough science in many circumstances, but that standardisation has to come. We've all got to agree on how we do it and what the critical control points are, and then those effective control measures. So if we're going to put control measures in, they've got to be suitable for the job. So how chemists solve those sorts of things? Metrological traceability. Does anyone know what the hell I'm talking about when I say metrological traceability? Good, some nods in the room. Okay, I might spend 2 minutes on metrological traceability. Statistical analysis, going all the way back to Atkins. No, I'm not going to talk about statistical thermodynamics right now, but from undergraduate hating it to postgraduate, absolutely, it was a foundation, a cornerstone of all of my research was being able to do statistical thermodynamics. It's way easier in the applied world than it is in the. I think I failed that that topic. So, that unit. And the exposure groups we talked about, the standardisation, getting a consensus across the science, and then I don't know, when I was at university, we talked a lot as chemists, and certainly when we were doing chemical engineering units, we talked about best available technology not entailing excessive cost, BATNIC down there. So that's found its way into, particularly into the safety world, but especially in the hygiene world. I don't really want to talk about stats. So I might just, no. No. Anyone want it? No? That's good. All right, so how do we make robust decisions? Well, from robust science. And I'm showing you two examples of probably not very robust science on purpose. So it looks on the surface, that is the surface, that they're doing probably a pretty good job. Don't really know. But I've got a number of issues with both these photos. I'm not going to dwell too much on them. This is actually one of our staff, and this went on social media, and the company were very, very proud of this really fantastic shot of somebody doing some air monitoring. The thing that my eye got drawn to first, absolutely first, behave, was the fact that she's calibrating nothing. So there's no sampling head in that device. So there's a pump in one hand and a flow meter in the other hand. But the point that I want to make is that unless the things that we're using to do the stuff are calibrated, metrological traceability, then sending a sample, sending a respirable crystalline silica head to the lab without good volume air measurement, if you're sending swab samples without actually measuring the size of your swab, I'm going to assume that that's a 10 by 10 template that's being used there. But it's up at the corner is the thing that I noticed straight away, and that's just a no-no in the craft. Wrong type of swab, and the gloves irk me as well. But moving on from that, if we're not sending in robustly sampled media that we know and understand either the volume or the area or any of the other in-field determinants, then we're not going to get a robust result back from the lab. And I really do encourage you all, if you're getting a result that's a mass per unit volume or area result from your labs, if you're doing this kind of work in the future, you question how they're doing that and how they're deriving that answer. Because in fact, if there isn't an unbroken chain of metrological traceability, if there isn't a NATA calibrated vernier caliper for that 10 by 10 that's being used, if that flow meter hasn't been measured against a primary standard for its precision and accuracy, then it's not a valid result. It doesn't matter. And that's how ultimately you're putting at risk the robustness of the information that you're generating from the data. We've got to make it effective as well. I kind of want to make the point that this is not the chemical plant. This is kind of like the R&D lab that they've got for this. I hope that I'm not putting because this is a real picture from just a couple of weeks ago. I blacked out the faces just in case because I didn't want to get in. But what I really liked was that because their hood, they've assessed that it's probably not going to be as effective as it absolutely could be, or it could fail, or the fact that it's sucking up, so it's sucking all the fumes, straight past the fact. So they've got these predator masks on with the self-contained, or not self-contained, so the powered air purifying respirator equipment on. This guy who's overlooking the job up in the middle, though, didn't. Which was a little bit of it. So this was the before photo, but we've gone in there and we've tried to assess the hoods and we've tried to assess the suitability of the mask and really have made it a much more effective process. I don't have the after photo for you at the minute. I am going to going to hunt it down so I can show people this in future iterations. I'm afraid I don't have it right now. But this is, does anybody know what that compound is on the left-hand side? It's methyl diphenyl isocyanate, MDI, which is a pretty toxic compound, and that's what they're working with. That's their setting agent, or their I think it's a catalyst for the foam, the gel rubber that they're trying to make. And there's quite a lot of that floating around in that atmosphere. It was measurable all the way around. So it was very good that they brought somebody in. Their main plant was amazing, pristine. Their little sort of R&D batching room, not so much. And it was, I don't know if you can see, it was sort of this hidey hole for these three more senior in the organisation, but more senior gentlemen as well. The point of the occupational hygienist is sometimes always to make it, is sometimes also to make it more profitable, or at least less costly. So talcum payouts so far are in the tune of $5.5 billion US, because somebody, a chemist, didn't disclose originally, and then the courts have said the company should have informed consumers of the risks. The risks were known and understood, and the chemists and hygienists that were employed by that company apparently were complicit in keeping it quiet. So to the tune of $5.5 billion so far, since 2016. There's 6 years of litigation, and there's more to come. So I'm going to take a slightly more serious note, noting the silica. That's not the only silica that concerns me at the moment, and this is something. This is my prime focus, and this is my sort of piece to the public. The incidence, occupational silicosis by industry and age. This is some research out of the UK. You can have a look. It was first published in 2018. It's been updated since. Unfortunately, in the older age groups, there's a higher prevalence of silicosis across all of those industries. But alarmingly, if you look at the uptick for the stonemasonry industry, and I think that's been particularly exemplified here in our own fair state of Western Australia with the artificial stone benchtop industry. WorkSafe, or as they're now called, the Department of Mines, Industry, Regulation and Safety, started a study back in 2018, I believe it started, looking at the industry in particular. And there were a couple of other industries involved in this, but particularly looking at the stone benchtop industry, they did 150 proactive inspections. They issued 1,000 enforcement notices. So that's a lot of enforcement. I don't know if any of you are actively working in industry at the moment, but you know what an enforcement notice is when you get one, because it makes the entire board shake. Air monitoring conducted with 75% of those monitoring events recording respirable crystalline silica levels above the workplace exposure standard. That's horrifying. 365 workers were required to attend health surveillance, and that'll be ongoing for the rest of their life, and 24 of those were found to have silicosis. That's in our fair state of Western Australia. So I don't want to put a dampener on the mood, but our role as occupational hygienists and the value that the occupational hygiene craft can get from chemists in particular, and our understanding of chemicals, our understanding of hazards, our understanding of control measures is absolutely essential. And that's kind of the message that I want to get across. We as chemists, we as occupational hygienists have to make this field inspirational, because it's not us necessarily, and I don't consider myself close to retirement age, but being now in my mid-40s, I'm trying to get the next generation of chemists to become hygienists. I'm trying to get the next generation to do it, because without them, the field is going to run into a hard time. So it can't be left up to the likes of me. It has to be the next generation, and hopefully these happy, smiley people that were taken for a Tetra Tech marketing campaign. I'm afraid I don't think it's a fudged photo, to be honest. Although I think I know where it is. If you recognise it, let me know. But yeah, these are the ones that we have to inspire, and we have to get out there, and we have to get more of the young chemists coming through, thinking about occupational hygiene, and not just about the process chemistry. So that's about it, I think. Yep. Thank you. I've been on LinkedIn a couple of times ever in my life. Keely, don't laugh. So if you do want to get in touch, then LinkedIn would probably be a nice, easy way to start. I can't help notice I might need to update my bio photo that was shown at the beginning. It's still sitting here on the screen. That one, I might have aged a couple of years since that photo was taken. So, but yeah, get in touch if you want to know any more about occupational hygiene. If you want to know about any of those weird and wonderful chemical reactions that I was involved in. I'm still a little bit of a science nerd, and get in touch if you need an occ hygienist.
Thank you very much. Do we have any questions?
Harry.
With the work in spodumene, I guess it's definitely an area where at the moment there's not a huge amount of legislation around the sort of silica aspect and the risk aspect.
Yep.
Are you seeing much movement in that space, or is that quite difficult to get across to a lot of companies that spodumene itself is quite problematic?
So there's two ways we can look at particularly these kind of more growth industries, more emerging industries. One is we can go and bash them with a hell of a lot of science and with a lot of this is going to hurt people, that's going to hurt people. We already have regulations around how much dust our workers can be exposed to, and as you can probably fathom from this photo, there's not enough attention being paid to dust, and specifically on the respirable dust side of things. Not enough attention being paid to it already. So if we go in there and start talking to them about heavy metal exposures as well, then we're just going to be falling on deaf ears to a certain extent, because these mine managers already know that they've got huge problems with dust exposure. This is in an exploration sense, so I don't know if you can see in the background. I've got some great photos from this campaign. The exploration side of things, good luck trying to get them to control their exposure to anything. Yeah. I was reading an interesting article that there's a mining company looking to blow up the hill opposite Whitney. I think I probably need to be careful what I say too much, but the hill opposite the Whitney Gorge. So as the Whitney Gorge spills out into the Whitney town site, if you carry on the other side of the floodplain, you've got the other side. It's got a specific name. It was a pretty famous cattle station at one point. And this is recorded. I wouldn't possibly say. And so the exploration drillers have been out there, and pretty much all of their equipment has been condemned, is contaminated with crucidolite blue asbestos. Quite why you would want to do it, I just don't even understand. But money is money is money is money is money. There must be billions of dollars to be made out of blowing up another hill full of asbestos, just in a different way to the last one. Hopefully. My team's just got back from Whitney. Unfortunately, we were involved in the eviction process, but some of the photos from that area, it's beautiful. I mean, it's stunning country, and you can understand why so many people want it restored and want it put back to how it should look. But man, I just can't imagine how to do it. There's millions and millions of tons of mine tailings all through, well, 3 gorges that all spill out into that floodplain, and of course the floodplain, which is covered in tailings.
Well, I'd love to have more questions, but if you've got some burning questions, please ask during pizza time. But yeah, thank you very much again, and we'd like to give you this
Oh,
as part of the RSCI.
thank you very much.
Okay, thank you very much.